So yeah, welcome back to my channel, welcome back to this channel, right? Welcome back. So in the last video we have looked at, in the last few videos you looked at the working of neural networks. You have learned about, how you can build your own neural network in Python, right? So you have developed your own neural network. And like, I really hope you have understand what's going on behind the scenes. Like, we are not, like, in the last video I have not coded the neural network for you to build this, right? If you want to develop a neural network in this age, you don't have to write it from scratch, right? You have a lot of libraries that you can use. So the main objective of the last video is to make you understand the behind the scene architecture, what is going on uh, behind the net in the deep learning neural network. So that is the main objective of the last video. And in this video, we are going to see how you can develop a neural network in this age, right? So how you can easily develop a neural network. We are going to use a library called Tensorflow, which is already pre-written by Google, right? So this library is developed by some coders at Google, right? So you can use their pre-written code on neural networks, and you can just start developing your own neural networks for your specific problem, right? So let's see. So we are going to solve a problem, like, not like, we are not going to solve this problem this problem is I don't think it is of any use, but to understand how to build neural networks in TensorFlow, we are going to solve this problem. This problem is called breast cancer detection. So sklearn is a Python library, right? So which can provide you some machine learning tools. So they have a data set. So they have some collection of data in which they have some features of a cancer tissue, and then we have to predict if the features, if the tissue has cancer. So we have to, given the features of the tissue, we have to predict the tissue has cancers. First, let's go to our dear friend. Let's come back to Google Colab. So in the last video I just wanted to code the neural network in replit, just to make sure that you can understand, just to make sure that you can write scripting in Python. All right. Mhm. Yeah, wonderful. So we have our environment open. Let's create a new notebook. So it is opening, right? Yeah, so we have opened a new notebook and let's start coding. So first, the first thing we have to do is load the data set, right? So as I have already mentioned in the first video, we need data to train machine learning model. So let's just load the data set. So the data set is from sklearn.datasets, import load breast cancer. So these are the steps to load the data. I'm going to say load breast, right? So using these two lines of code, we can load the data set. So in this line of code, we are just activating the library. Okay, we are activating the library. uh, to be precise, we are activating the function of the library, and the function is load breast cancer. And then after that, we are going to call this function, and then we are going to store the output of this function. So this function will essentially output the data set for us, and then we are going to store this data set, the output of the function, in this variable called data, and you can just run it. So we have two main objects of this data. The first main object is data.data. So using this variable data, so we have this variable data, and then we are saying dot data. We are going to get all the values of the data set. And so here, these are the features. Right? So this is the first row, or the first element. So we have lot of elements, right? We have lot of tissues, and this is the first tissue of the training data set. This is the second tissue, and we have I think we have many. I think we have many, right? And then the next thing is, next attribute is data dot target. So these are all the target values, right? So we will just get all the values. If I think it is zero, when if the value is zero, then that means there is no cancer, and if the value is one, that means there is cancer for that specific tissue. So for the first tissue, right, I'll just open it up. So for the first tissue there is no cancer. So this tissue, right, so for this features there is no cancer. Hope you understand what is going on here. Sorry. Okay, now let's code the model up. First we have to import TensorFlow. TensorFlow is a very cool library, and there is also another library called PyTorch, which is developed by Facebook. But I think TensorFlow is just easy for people to work, and when you are especially building sophisticated models, right? So when you are building huge models, or probably um, any models that are created in the current research papers, right, in the current research in our in the AI community, yeah, using TensorFlow is just like very easy. So whenever I also try to read any papers, I tend to go through code that are wrote in TensorFlow. So TensorFlow is a very good library, and it is very to use for beginners. Now let's develop a model. Let's see the syntax of developing a model on TensorFlow. First we should create a variable. Of course we have to store this model, right? So in the last video, remember, we have created a variable called network, right? We have created a variable called network, and we created a list of all the layers. So this is also quite similar in TensorFlow also, but we should not create list, but we have to create a object of Keras models. So we should just write this TensorFlow. Here TF is nothing but the variable name of TensorFlow. So I'm just importing TensorFlow as TF. So rather than writing TensorFlow, typing the whole name, I can just whenever I am referring to TensorFlow, I can just use this little two letter word TF. Right? TF.keras models the sequential, in which I have to input a list. So see, this is a list, and then in this list I can add in the layers. So let's say I can just add in layers dot dense. So you know about dense layer, right? In the last video we have coded up. It's quite similar to what we have built in the last video, but using this we can build powerful models. All right. Now we can add the number of neurons we want. We don't have to specify the input step, which is kind of a luxury whenever you are building deep learning models. Okay, so tf.keras.layers.dense, how many neurons we want, you can type in anything, right? Let's say I want 512 neurons, and then here I can just specify the activation function. So I told you about activation function. Here what does ReLU do is, this ReLU activation functions helps you to remove negative values, right? So whenever you are computing an output, if you have negative outputs of any neuron, if any neuron's output is negative, then ReLU will convert it into zero. So any negative value output will convert it into zero, and all the positive values will remain as the same. And then let's add another dense layer. Let's say I said one dense layer. So let's first experiment by building the simple model, very simple model this is. And then the activation function, you probably would have heard me saying in the past, I think one of the past videos, that whenever you're doing a binary classification, you should use the function called sigmoid. So this sigmoid function essentially helps us to convert the neurons output between the range of 0 and 1, which can help you to um, make the neuron as a classification output, right? So you can just define this simple model, pretty simple, right? Even like if you have watched my previous videos, you can just, it's just a piece of cake. Now we have developed this model, right? Now before training our model, we should first do something called compiling our model. So what is compiling means, we have to specify some parameters. Right? So compiling is essentially is specifying some parameters such as optimizer. Number one, we should specify the optimizer that we are going to use. So optimizer is nothing but the like which algorithm we should be used to optimize the weights inside this model. So it is not actually that important. You can just add optimizer works always the best. I'm going to make a video on that. I'm going to make a video on that. But presently, as we have I'm just going to go through deep learning as fast as possible at first, and then we are going to go in depth, after we cover all the base research and all that. So optimizer, we specify the optimizer, and then loss function, we should specify the loss function what you have to do. And then there is a loss function for a binary classification, which is called binary cross entropy. Right, so this is a loss function, in which, right, so whenever you are doing binary classification, it is very very easy, very simple, in fact. So we are going to, like if like it is just computing loss between zeros and ones, right? So let's say the actual answer is zero and the computer predicts one, we are going to add loss. And if both are equal, we are going to not going to add any type of loss. That's it. So binary, this loss function is just helping us to uh, helping us to guess how better the prediction of the model is, because the values are zeros and ones, it is pretty simple. And then we can add any metrics. Metrics means the values that we want to see during training, right? So during training group, at every iteration, what are the values, what are the parameters we have to we want to see. So let's say we put in accuracy here, that is at every iteration, right? So that every iteration of training, whenever the weights of the model are updating, using the process of back propagation, we are going to see how well the model is performing. That is how accurate is it. That is the number of predictions it got right, but divided by the total number of uh, tests. And then after we compile the model, training the model is very simple here. We can just do it something like that, model.fit. So we are going to create a variable called history, in which we are going to store all the accuracies and loss of the model, right? So we are going to store the increase in accuracy and decrease in loss, hopefully, in this variable called history. And then we are going to train the model. To train the model, you can just say model.fit. So model is we created model here, right? We have compiled it, model compile, and then we'll fit it here, right? So we should in the fit function, first we should specify the training data, or the input data, right? So what are the inputs? Well, the data inputs are data, right? So if you in this data, we have all the features, so we input data, and then we should specify the answers. What are the actual answers? Data.target, right? So I just showed you what happened. So this is the inputs and this is the outputs. And then another parameter is epochs. So what is epochs is the number of times you have to update or do back propagation. So you can just specify number. Let's specify a big huge number. That's something like 100, and then that's it. Simple as that. And you can just run it, and it starts training. It is pretty fast, because the data set also pretty good. Okay, we have achieved a pretty good accuracy, 94%, which is like very good for task like this, where we have multiple features. Let's try doing let's say adding more neurons here, just to see if accuracy increases. Let's add another layer. Let's add 1024 neurons, or something like 256 neurons. Activation equals dilute, right? Let's just try to add some more neurons, one more layer with 256 neurons. Then we're going to compile it, and then let's train it. Let's see if the accuracy increases or decreases. It will increase, I think. Let's see. 90%, 92%, 93, 96, 94. Okay, 94%, almost as equal. Okay, because this data set is not so complex, we have only one set of features, that is like I don't think we need these many number of layers and neurons, but it is the accuracy is good. Now if you want to visualize the results or visualize the performance of the model. That is why you can use this, the variable we just called history. So what you can do is, let's import a library called matplotlib.pyplot, and then we'll name it as plt just for our simplicity purposes. And then what we can do is we can plot this the performance of the model. We can just say plt.plot history and then accuracy. We can just plot the accuracy. Let's do it, and then we'll get a plot of accuracies. Okay, so yeah, it started off, the model performance started off at 65%, and then it increased, and there has been some up and downs, right? So that actually, when you have a more zigzag number, when the line of accuracy is more zigzag, that means the model isn't performing that well. Maybe we like, there is no point in training this much of time, or this many number of epochs. You can just quit training the model at a specific number of epochs. So like, I'll talk about that in future. So yeah, this is it. This is very easy, right? So developing model in TensorFlow is pretty easy, especially at this age of neural networks, right? We can develop powerful networks. Whenever you are developing powerful neural networks, like doing in Python is almost very hard. So but using TensorFlow, you can um, just get your ideas alive, get your ideas of deep learning alive. And yeah, thank you for watching this video, and then see you in the next video. In the next video, we'll do CNNs, image classification, right? So we have already talked about the theory of CNNs, and then we are going to develop CNNs in pure Python, right? Let's In the next video, we'll do image classification. Thank you for watching. See you in the next video.